Okay, so on this day, students are going to determine when expressions with common addend have the same value. And you're going to see what I mean by that in the very same task. Like when we ask basically like, are these both equal to 18? And no, they're not. Why not? The main idea they get from here is like, you can't add a different number to the same number and expect it to be the same. Like 14 and 4 and 14 and 2 are never going to be the same because you started out with the same number, but then you added different things. That's the main idea. Now, well, I should say that's what they're exploring here. Now, why is that important? Well, down the road, we're going to want them to add this. And we're kind of already getting to this in the previous day's lesson with a complement of 10. And we want them to know that this only works because we have the same number getting added to really the same number. In other words, I can't do 9 and 4 and 9 and 1. That's never going to equal up to the same value because I'm not putting the same parts together, right? When I have the same start, if I want to preserve the value, what I add onto that start also has to be the same. That's kind of the understanding we're getting at. And so we're doing it in kind of a backwards way where the examples are done for us and we're just talking about like, no, these are not equal. How do I know, right? We can talk about parts and wholes here, right? We can talk about how we actually finally got the total value and the total value and they didn't add up. The number we started with was the same, but what we added on wasn't the same. So of course we won't end up in the same spot. All of those are great explanations, but this is really the fundamental idea, that thinking about when we keep the value the same. One other thing that's really important about this, we're really focused here and even here, not so much on the actual numbers themselves and what answer we get, but we're focused on the structure of the equation and what we notice as more general similarities and differences between equations. This is really, really important. And it's really getting into algebra. It's when we stop looking at the really, really specific values and just worry about getting an answer, and we start to see bigger commonalities. This is part of what in Common Core is called the mathematical practices. This is the wording of the mathematical practices in Common Core, and it kind of breaks it down for you, right? Mathematically proficient students look closely to discern a pattern or structure. Young students, for example, might notice that 3 and 7 more is the same amount as 7 and 3 more. Notice it's different than finding the answer to that and the answer to that is the same, but they can kind of generalize a rule, right? This is really, really, really interesting. They can take a step back for an overview and shift perspective. They can see complicated things such as algebraic expressions as single objects or as being composed of several objects. And here they're giving us an algebra example, but if we go back to here, right, it's more like instead of seeing this as 14 and 4 more, 14 and 2 more, they're seeing this as 14 plus some amount. Just like this is 14 plus some amount. The amounts are different, so the answer is different. All right, I preached to you enough. I know that I can get a little, tedious with that. You basically present them with this task, and you ask them, can these be equal? Right? And they might say they're not being equal by actually having to go through that way that we said, where they don't have to solve, right? You bring them back to the carpet, you start with a turn and talk where they explain this thinking to their partner, but then we're going to have 2 kids share out. You will have students here, and you can have more than one, who had to actually solve both number sentences, right? Adding on, fingers, pictures, right? But then here, you need a student, right, who could just look at the numbers and know right away that if this equals 18, this is not going to equal 18, right? As they come up, you're charting their work and their words and making the flow really clear so they can see what they're doing, right? When you talk about here, you can ask questions like, and this is going to pop up for you, right? Like, what do you notice about the numbers in both number sentences when you solved it? Why do you think you got a different answer? So that here you can say, What did you notice about the numbers in both number sentences, right? Could the number sentences ever have the same value? Why not? And I put that question up for you as well. So instead of giving the kids a thinking task kind of as they go, instead you can have people share and then do the noticing, right? So you're really trying to notice some kind of bigger pattern, right? Then put up another problem on the board and have another discussion, and hopefully you've got more kids on board this time. If you do have kids who aren't necessarily here, you can be asking them these questions during the work time as well, and maybe letting them explain. Maybe then that'll jog something for them. And so then it's work time. Now, in this case, you really want to do the first problem together because it's just a little bit trickier than it has in the past. But you're doing all the problems together, and so I think that it'll be fine. Like, you're used to reading them. It's just you might want to take more of a lead.